So, hello everyone.
Hello, Professor.
Hello, Professor.
Okay. We have two students, yes?
Yes, Professor. I think there would be a problem with most of people's edu.ortulv's emails because some of them are not receiving it.
Okay, but they have schedule at least, and they have to go to the Ortus, and in the Ortus they have all information, because these mails are not, this is some kind of voluntary thing, yes? The
Okay.
students must
Professor,
be
I
informed.
have one more question for you. Students coming from India have been vaccinated with COVID shield, but what they told us here is we have to get it verified from the European Health Services, and the process would take around like for a month. So is it possible that we can have the classes online for the first few weeks?
No, it will be completely online. Yes, it's not
Okay,
a
Professor.
problem at all. Yes,
Okay.
this in the first lecture I'm going to explain you all those things actually. Now that's why I wish to have more students to note this question appearing, popping up several times. Yes, and
Okay.
yes, because okay, I decided do it online, and because of many students are not still vaccinated, and all these problems with all this recognition of these vaccines, and so this is a lot of issues coming around. So in the first lecture, I plan that I will introduce myself, that you will introduce yourselves, and I will talk a little bit about the course, how it is designed, what are the rules, what we actually plan to do, and then we will maybe a little bit talk about also software-defined radio. But one important thing that in the schedule, it was scheduled 2 lectures each week, but this is not correct. Yes, yesterday I asked to adjust the schedule because this is a 3K credit point course, and that means we need 2 lectures only on odd weeks. So this week we have 1 lecture, and the next week we have 2, and so it will go like this.
Okay, Professor.
And okay, let's go first. So my name is Artūrs Aboltiņš. Yes, you can see it from Zoom and also from the schedule. I'm the associate professor in the Faculty of Electronic of Telecommunication, and I've been working here approximately for 12 years. Yes, and currently my interests are related to signal processing. This I'm teaching also bachelor course signal theory for the second year, something approximately. For international students, this is a little bit different, and also for this course. And before I read also computer studies and so on. And I'm doing research mostly on some communications or on wireless communications. This is also, of course, is software-defined radio, but now I'm doing a lot of work on the ultra-wideband communications, where we do not have still any software-defined radios, but this is, I see it's very, very, very prospective directions in which we can do anything, but it requires a lot of expensive equipment. And before the university, I came to the university in 2008 to write my PhD. I finished my PhD in 2013. And before this, I was working as a programmer, and before this, I worked as an engineer for the telephone company. So something like this. I graduated from the university in 1998. Yes, so I'm like quite already old. Yes. Okay. How about you?
I'm myself Naveen Ulamurkan Professor, and I'm from India. I did my bachelor's in Anna University from the southern part of India, and I've come, and then I was working in a sales field for almost a year in an edtech company, and then I joined here on 2021 for the January intake here.
Okay. Do you have the cameras? Because if you switch cameras, it could be nice. For me, it will be easier to work because it's at least because it's really difficult if I do not see person. And nowadays, with this remote courses, you never, sometimes you don't ever have seen this person at all. Yes, and
Yes, I understand.
you meet this person into university and you do not recognize it because you have never seen it, and this is like little.
Yeah. Yes, I understand.
Yes, and okay, and Astil.
Hello. Yeah, my name is Astil Peter, and I'm also from India. And I graduated my bachelor's in 2019, and I don't have much of a work experience, so directly joined masters here in the last September intake. And now I am working in EDA with something called high performance computing, and I am in the third semester now.
Okay, but you did. But what is the company?
EDA, Electronic und Dator Institute.
Ah, I know this Eddie. Okay, in Teika.
Yeah.
Okay.
I am there
are
as
you
an
working
intern.
there as a scientist or?
No. I am just an intern. I started work around only 1 week ago.
Okay, but that's nice because this is a research institute. This is could be quite interesting and well.
But we have mandatory course internship in our course. I mean, I have to do 12 hours of internship per week in this semester. So I am considering that.
Already started, yes? Ah, yes.
Yes.
You are not first year student.
I am second year.
Okay. And Naveen also second year student.
Yeah, I'm second year, fourth semester student. I'm almost past my internship. I'm doing my internship with Event Tech, and my supervisor here is actually Mihail. He teaches at RTU. Mihail Sports. Yeah.
And so, who is supervisor?
It's Mihail. He teaches at RTU.
Ah, Puch.
It is FPGA. Yeah. Puch Mihail. Yeah.
Mihail Puch. Okay.
Yeah.
Fine. Yeah. Yes, I also do. I just recently this project about ultra wideband radio. It also deals with Event Tech quite a lot.
Yeah.
Because I'm integrating this timer into communication systems, so I'm quite familiar. Okay. Oh, that's nice that you are sometimes in the university.
Yeah.
How it is, like completely remote now?
Yeah. Now the problem with me is like I've come home for vacation to India, and I took my vaccination here, and I have to get my vaccination verified with the European Health Services. But it is the same vaccine, but they want to make sure that it is valid. So I took AstraZeneca here. AstraZeneca is also in Latvia, but they want to make sure that I have taken the vaccine, whether it is an original document or it is a fake. So they want to make sure the process of making sure it is a valid vaccine, it takes around like 1 month. So I was afraid at the beginning that I would be missing the entire semester and I would have to take a repeat of it. And then like luckily on my side, you have made this online, and Mihail's also has made the courses online for the first 3 weeks.
Okay. But this is what's COVID shield, not AstraZeneca.
Yeah, this is COVID shield. Actually, it is AstraZeneca.
No, yes, I know that this
yeah,
is quite
yeah.
similar. And
Yeah.
but I have some students from India saying that AstraZeneca is much better. Oh no, they was trying to get Pfizer. That's why they was not big fan of this COVID shield. And I have one student, one lady saying she was so happy that he got vaccinated here. So
yeah. Even now I'm feeling like I could have got the Pfizer when I had the time. Like when I was departing, that is when they were allowing all the international students to get the vaccinations. So I thought, why not go back to India and then get the vaccination and be there? It would be safer for me. Then all these problems rised up, and it is very hectic for me. I have to send it to the Indian embassy. They have to verify and apostille it, and then have to show it to the Latvian government. Yeah.
Yes, I believe, because this could be some kind of not question about the vaccine. This is the only question about if it is not fake document. Yes, I think
yes,
is the problem.
Yes.
Because I do not see because it's easily nowadays to everything to get
yes.
fixed. But okay, fine. So how much students do we have? Okay, I will share the actions, security, but where is the share screen? Okay, this is the green button, which I do not see. Okay. I have some problems with my computer. I hope that it will not restart, because I have already today lectures and it restarted several times. So hopefully it will not happen. But the reason is the cable. There is a problem with the power cable. It sometimes do not charge anymore the computer, and then it shut down the last time. Okay. So what I wish to see the participants, because it was like okay, but there is never attended, never have been in Orto. So this is like some kind of maybe not completely here or something like this. Okay.
I believe that
Professor
Swami
Aravind has gone
for
to Erasmus.
Which?
The last one, Aravind Swami Vallam Sundaram.
Aravind Swami, okay. And those two, do you know them?
Yeah, like Sangeet has been recently married, and he's in India, and he'll only be available from October 1st week. That is what I got information from him as I have got.
Okay.
I think he had mailed you regarding this, and I don't know about what Gopinath is doing.
Okay, but you have seen him ever? Because it must be second-year students. They all are.
Yeah. Gopinath and Sangeet are both my batch, professor, actually.
Because I see that all they started studies in 2020. Yes, this is first digit.
Yes.
But I am from the different batch. I am from the September intake. They are from January intake.
Okay, you have a half-year shift, yes? But you have earlier entered or later?
No, I am later. Okay. I am only in third semester now.
But then you will defend in where? When?
What defend?
Your master thesis.
My master's thesis in next September.
So that means that you defended something about the Christmas in the next year, yes?
Like I have to choose a master thesis like in the semester. I'm in the fourth semester actually.
But you have 5 semesters, yes?
Yes, 5 semesters.
Yes.
That means that your defense for Naveen, the defense will be something like in summer, yes, of this year.
Yes. It will be like somewhere in June. Yeah.
Do you have already started writing your thesis?
No, Professor. Like I would be choosing my thesis this semester with something related to my internship, or if
Okay.
there is any suggestions that is given by professors.
Yes, but if you have a supervisor for internship, and usually the thesis is bounded to this internship, this is good practice, and I think if we do Eventech, maybe we can also.
Okay.
If even
Because I'm really out of ideas for my thesis.
Because I would have some ideas, but let's talk maybe about this later, because if about
Okay.
Eventech, we can do a lot of research, and
Yes, Professor. Yeah.
and I'm going to, until Friday, I have to put a list of theses into the official document, and maybe I will send it to you, and you can decide if you are interested in this kind of
Yes, Professor. Yeah.
things. And
Okay.
even we can talk about this, and yes, and of course also it also depends also on the student, yes, because I do not know any one of you, and it's very risky also take some student which you do not know. So I will have time also to think, yes, let's say, because it's a lot of work anyway, but it's good if you take some internship, of course, because you have some information and you have also support for this, and something like this, and maybe if you plan to do something after the masters, it could be also useful to take some topic of this. But of course, the most important is defense itself and this document, because if you need to do this in time, and this is, you must concentrate. Yes. Okay, good. Let's go with the course rules. Yes, I little bit explain about the course. And this course in general is oriented to the practical. Yes, it's solely practical course about doing some experiments with the software-defined radio. Yes, we need software-defined radios for doing all experiments. And you can get those software-defined radios. You can rent it from RTU. This is a guy. I have not talked with him, but I think like tomorrow, I will talk with Yanis, because he is almost always in the university. And then you call him and you can sign some agreement about the rent of the equipment, and you can get this Adalm Pluto device. Yes.
Okay.
It costs about something like 200 euros. And if you lose it or disappear with the device, and then
you have to pay
try to recover this money using some legal things. Some of the students buy those devices, but I don't know if it is necessary, and if some has.
So even labs will be having it online, Professor?
Yes, but you don't you need computer, yes, but you must have a computer. Just because this is a simple thing, you connect the software-defined radio to this computer. You need MATLAB and GNU Radio.
Will we get access for MATLAB from the university?
No, this is a problem. Yes, but also we can also connect remotely. Then, and I can organize some work places with a MATLAB.
Okay.
And if you have, by the way, you can go to the lab, and if you have valid certificate, for example, you can go to the lab and do it from the lab. In the lab, you will have software-defined radio and MATLAB and everything in place.
Okay.
And I will connect remotely, and we can do this. And another, you can connect remotely to MATLAB with the software-defined radio. But then it's not interesting, because if you cannot touch this device, you cannot. It's I don't know if it does make sense, because it then will look like simulation, because
Yes, I understand.
because you cannot check if is everything working. For example, even sound, when you have some, we will building some radios. I don't know if it's possible to send the sound over the network back, and I think this is not interesting at all. And much better than it's find some kind of, I don't know, because there is a student versions of MATLAB, but I don't know how they are functional, how well they are functional. And in the second part of the course, we will use GNU Radio. This is free of, this is like open source freeware. You can install it and there is no problem. But with MATLAB, I don't know, even you can find maybe some cracked version. I don't know, because yes, this is
There's a cracked version over there.
Because I don't know, I cannot fix this. Yes, this is like
Okay.
emergent. We have full class with MATLAB licenses and SDRs, but we cannot use it in this situation. You can rent the hardware, but you cannot rent the MATLAB. Yes, because its licenses doesn't allow to give this license outside the university. Even
Professor, last semester when we had Cadence with IC2, there was MATLAB like available.
Not MATLAB server. We have this, but yes, but the problem is that software-defined radio use MATLAB in very strong manner. It has, you connect the software-defined radio to computer. It sends all samples to this computer. And it needs very high bandwidth for the connection. If MATLAB is remote, it will start lagging. And even in multi-user mode, also it barely can cope with one SDR. There is no impossible to any multi-user or even multitasking. Even if I run Zoom on the same computer, it start to lag and make some. Those software-defined radio systems start failing because they do not have enough power to do this. We need powerful computer, clean, and do not run anything in parallel. And if you connect remotely, most likely it will fail. If you sit in the class with this SDR, okay, it will work, yes. Or if you take SDR home and connect to your computer, it also will work. This is a practice. I, for example, run two computers here, one for Zoom, one for SDR, when I do labs, because otherwise it will not work properly. And a lot of students also complain that, for example, if they are in the Zoom and the same time they try to run.
Professor, about collecting the hardware, I will not be allowed to get into the campus without the certificate. So how will I be getting it?
Oh, this is very interesting. Okay, we can bring it outside the building.
Okay, but I think I can bring a negative PCR certificate because this is allowed until October 1st.
And then after October 1st, what will happen?
Then after October 1st, I have to provide them a valid EU interoperable certificate.
Okay, you promised it, yes?
Yeah.
Okay, but
like I have already applied this in the latvija.lv and the process has started, but it will take, they told us that it will take a minimum of 1 month time.
Okay. Because the first labs are without SDR. I think the first lab, next week it is like we have a first lab. This means it is like today is 7th, that means 14th. Yes, in the 14th we have lab. Without.
Is it possible that Astral can collect the equipment for me such that I could sign him and give it to him? Then I can get it from him.
Yes, if someone else could, but you need to sign this document only and give
if it is available in email, I'll make a hard copy of it and then I'll sign it.
Okay, I will find it because I have used only Latvian version, but I have my director said that we have English version. I will put this
Yeah.
English version into Ortus.
Okay.
You can download, print, sign,
Okay.
and then you. Okay, there is. I just will notify the person about that it's you, because otherwise someone could fake. Yes, this easily, because if you don't see the person and don't know, that it could be a little bit dangerous. But
Okay.
you sign.
I will also send a soft copy of it to your email confirming that I have signed.
Okay, good.
Yeah.
And then someone else will come, take the equipment, give your document. Yes, your signed paper. We collect the signed paper, and there is some deadline when you have to return it. After this, if you return it and it works, everything is fine and so on. So it's possible. Yes, it's not a big deal. Yes, also one of the variant. And if just you need make sure that you have MATLAB and enough powerful computer. Otherwise, you go to the class this time. Okay.
So what should be the specification of the PC to work this properly? I mean, what should be the processor and the RAM?
I don't know. This should be like at least something like, I don't know, like 8 gigabytes of memory, at least Core 2. No, even I think Core 2 will not run, like i5 or i3 processor.
Oh,
It's not a big, like you cannot run in very old computers, like 10 years old computer will not work. Yes, 5-year-old, okay, fine, it will work. And nowadays,
okay.
but you also make sure, do not install, but the models, because the MATLAB, each version becomes more and more hungry. Yes, like this unbelievable, but even on old MATLAB, something works much better than in new. Yes, and I don't know what they do this, because many people complain about this, and that's why many people start to use Python, for example, in many tasks instead of MATLAB, because it's 10 times faster in machine learning, for example. Yes, and I don't know what they are doing, but this going somewhere in the wrong direction. It becomes very, very heavy system. Okay, it's convenient, of course, and we are used to it, and that's nice for something easy. But if you need some, for example, machine learning, if you have to train neural network for, and that's big difference if you train it for 1 day or for 10 days. Yes, it's huge difference. Yes. Or 1 hour or 10 hours. And this is exact the numbers. This is 10 times slower. Unbelievable. Maybe it's because of the wrong programming. Students could do this easily, but also the Simlink becomes slower. Okay, this is about the hardware. The next thing what we do is some rules. Yes, attendance is registered. You have to register attendance into also some special list, but okay, this is now virtual, and this is kind of, but still if you are attending lectures, is also information is fixed, and it will impact like 20% of the score. People who are not attending will be scored lower by 20%, because this is like, also they will have a lot of questions and user results are poor. Lab works must be submitted until specific date. There is a section when you upload the lab works. Yes, for example, here, I will redo this course because I do not like layout now, how it is here. This is from 1219, and now I have teach not tough for the international students for a couple of years, but I have teach for Latvian students and I have a little bit different layout and I will copy it here also. And if you are late, it will affect the final score. And if the labs are not submitted, you cannot go to the exam. But exam is quite, okay, this is like only 20% of the score. Because it will be kind of remote exam where we will do some system, and this is very difficult to check and so on. Finished labs give you 4 or 5. Individual task. There is one individual task. This is like a coursework, which you have to do during this semester. You can choose yourself, or maybe I will prepare some list and build something using Sofind Radio. Build this system, prepare report, demonstrate to the others, and you will get some additional scoring. But of course, it's now very difficult to choose because you do not have any experience in this, and maybe you can do it a little bit later. Okay, this is all works. This is the same thing. This is not the right information, but okay. This is lab works, individual work, attendance, and exam. This is a system of this course, but mostly, practically speaking, is the lab works are most important source of the score, because we do it in the class. I know if person is attending and have some results, I look to the reports and I see that they are not copied from anyone. It's original work. Then score is much higher, because especially in large groups, students try to copy, not do the work, especially at the end of the semester, and then this will be prosecuted and the score will not be very high in this case if I get this noticed. If I noticed copying of the laboratory works without doing them actually. Okay. Okay, what's else? What I wish to say else here? About the hardware I already have said. And okay. Maybe some words about the hardware. I will show you. Now I'm at home, and here I have also lots of various software-defined radios, and we will use this one. Yes, this Adalm Pluto from Analog Devices. This is kind of system. It looks like this. You see, this is like.
Okay.
This is device. It has 2 SMA connectors here on this side. Yes, and here you connect transmit antenna, receive antenna, and it has power about like 6 milliwatts. And we will little bit talk about this hardware in the lectures, which will be in the next lecture when we will talk about various hardwares. And here on this side, yes, on this side, you have USB port, USB 2. This USB 2 goes to the computer. You can imagine this like a sound card, yes, but sound card not for the sound, but for the radio waves, because it doesn't have very much intelligence inside. It just emit radio waves of a certain frequency or receive radio waves of a certain frequency and then convert those radio waves to the data and send them to the computer. All the processing is done on the computer. Only this down conversion and filtering is done in this small box. All the rest is done on the computer. That's why it's called software-defined radios, because everything is done in the software, actually. And that's why nowadays this is very popular directions. Actually, of course, here we have only two big chips. We have like a modem chip and some system on chip for the controlling all this. Like, I think there is some kind of, I forgot this name, but this is Simlink system on chip. And modem from the analog devices. It's modem for this LTE for 4G modems. This is a chip for the 4G modems, which you use when you have 4G something. And this device can work into the frequency range from approximately 50 megahertz until 6 gigahertz. Yes, you can emit and receive any frequencies. And I have some smaller, like this also, SDR, like this is Lime SDR. Like also with USB connect, and it can plug directly into the computer. And this also works something like 6 gigahertz, but it goes down to approximately 30 megahertz, and you do some experiments on the short waves, but I did try, it was not very well working. And finally, we have very cheap SDRs like this. Yes, here you have antenna connector. This costs only like 15 euros. You can buy this on eBay or AliExpress. This is TV receiver, actually. Yes, this is a RTL SDR. Normally, comes into the plastic case, and you can buy it for like 10 or less euros. But this is in metal case, and it's a little bit better. And actually, was designed for the receiving TV, but you can reprogram it as receiver for the software-defined stereo. You cannot transmit with this cheap device, but many experiments you can do with the reception, because transmission is relatively easy compared to the demodulation and the reception of the various noisy signals. And if you connect everything properly, yes, with this device, maybe I will try to demonstrate how it works. I will take this cheap one, yes, and run MATLAB and show how it works. And then in the rest of the lecture, we will spend with some theory and some ideas. But I think to get some inspiration, I will show you what we actually are going to do in this course. And this is also will be like one of the first lab works. Actually, it was the first one, but because of all these delays, I start thinking that maybe we can exchange first and second in order to have time to rent the equipment and so on. So because the first lab is on the next week, and I'm not sure that everything will be resolved at this time.
Professor, did we have class on August 31st?
August?
Yeah, because in the schedule it showed that we had class on August 31st.
Oh, no.
Okay. Yeah.
Lecture starts at the 1st of September. So
okay. Yeah.
It's never. Just today we have very first class.
Okay.
Okay. What I do now, I will take this and take some antenna. We have such antenna, and with the cable, we have also such antennas, but now I think all they are rented to the Latvian student, but they should return equipment because they was rented at the spring, and some still are not finishing. They work. Okay, I connected like this, you see. There is my, okay, it's difficult. Okay, I connected to SMA, my antenna. Hopefully I'm now 100 kilometers from Riga. I don't know if I will be able to receive anything. I still hope that it will be possible. I plug this into computer. But I need some USB port, which is not very close to others, and this is a problem. Okay. Okay, plugged in. Okay, where is my MATLAB? Now I will share MATLAB. Share MATLAB. Okay. Now I go and find my receiver model. Actually, this is very easy to build. Like, okay, even like only 2 boxes. FM receiver. But this is a Pluto-based FM receiver. Okay. Then I will take Pluto because otherwise I have to adjust the model and this could take time. But okay, let's try. Not a big deal. Okay, this is a Simlink. Are you familiar with the Simlink?
Yes, Professor.
What you studied with Simlink?
In signals, we had Simlink.
Oh, okay. In the last year, yes, signal processing systems or something like this. Anna Litvinenko, yes.
Yeah.
But we haven't used much of the Simlink. We have used only MATLAB only.
Yes, you use a lot of MATLAB.
Yes, but not the Simlink.
Okay.
Both are different, right?
Now this is a big difference. Yes, it's like
yeah,
completely. This is MATLAB is mostly command line, but Simulink is a graphical simulation.
Yeah, we have only used only command line, not graphical.
Okay, then you will try to learn it. It's not difficult, but just okay. There is a lot of some pitfalls and some hidden things which are not that easy, and students always are angry on me that I have not told about this and this and this, and it's yes, Simulink. Also, MATLAB is quite complex software. It's not for the students, and you can easily break it with some incorrect settings or forgetting to do something not obvious. I will try to stress all the things which are not obvious but important. Okay, where is my model now? It's not open yet, I think. Okay, I have to close.
But we have used Simlink only for advanced electromagnetic simulations. Only one model.
Advanced. Oh, so, but it's in different courses.
Yes.
Because I see that my computer also becoming really, really slow. I'm trying to close all programs, all unnecessary programs. It's like, but I have also, this computer is like 6 years old already. So planning, but I like this machine. That's why I'm still sitting with it. But it is becoming really slow. It has only 8 gigabytes of memory, and like I can, when I sit to newer machine, I feel that my old one is old. So here you see the model, yes?
Yeah.
This is like, when you build the models, you just take the library, yes? Library browser. Here you have a lot of blocks, like a lot of them, yes. Also for the communications, this is a full MATLAB with all toolboxes. And if you have some shorter versions, you do not have all blocks. And you just drag those blocks to the model, connect them. I will do this I will explain, also show you some examples. And here you just, for what you do, you take block for, we need, for example, now I have put some RTL as their receiver. So I remove this. Okay, I will save as something different because not to damage my model. So slow. Okay, this is like RTL. Surprisingly that I do not have RTL model. Here I just go and find for RTL SDRs. This is green box which I have plugged in. RTL SDR receiver. Drag it here. So here we just double click, open, and adjust the parameters. Here we can just say that the source of the frequency is input port. Sample rate will be 240, I think. Would be nice. Output type. Sample rate. Is it good? Connect this port which dictates the frequency, and this port which sends out the data. This is actually data which comes from this box. And in the software, we have FM demodulator and sample rate converter. And here we also have spectrum analyzer. And we can run this. For simulation, we can also set a lot of settings, but here we can like.
Also, why is there floor in between constant and RTL SDR receiver to flow down the value?
And yes, floor, it rounds all numbers down to the nearest lowest integer. And this is necessary because Pluto doesn't accept floating point frequencies. It doesn't accept only integer frequencies. So the step is 1 Hertz. And that's why we need this floor block here. Okay. And this is just tuning frequency. It adjusts this number. Now it's 104 megahertz. And then it goes rounded because you see there is a lot of numbers after this comma. They are get removed and sent to the RTL. RTL actually do not need this floor block. It will block also with floating frequencies as well, but it will work also with integer, no problem. Because 1 hertz is very small step. It will not affect any tuning of air or anything, because frequency is 100, about 100 megahertz. That's one hertz is only 1 millionth part of the frequency. So this
Okay, boss.
SDR inside has, of course, a lot of various hardware and various devices. But actually, this is like RF tuner. Okay, this is some problem. Okay, this must be divisible by 5. Yes, believe. This number must be like, okay, we can give even like 2,000. Usually even 10,000 could be okay. This is a buffer size. This is a packet, how many samples get sent in one step over the USB. And the bigger is the number, the lower is the traffic on the USB, because otherwise, if you have very small packets, they will have need to be sent very frequently over USB port. And sometimes it leads to some underruns, because it will not be able or overrun on the SDR side, that it will not, the computer is not able to consume samples at this rate, because this is a USB 2 connector. USB connector, this USB 2 can handle maximum like I don't know, few megabytes, maybe 5 megabytes per second, not more. It's like maybe like 50 megabits, yes, not more. If some SDRs have USB 3 connector, or even we have in the university very expensive ones. Okay, do you hear it? Okay, then we can try to tune to some station. But I see there is a lot of noise coming right now. Okay. It's lagging because there's not enough computer power.
Professor, actually we can't hear you. Like, there is only some static noise.
Yes, this is like only noise, because I cannot get any station here. Maybe I'm too far from Riga. Maybe my antenna is too low. And okay, let's try one to put some certain frequency, like 100 megahertz. Exactly, because I know there is a station, or there is a local station at something, but I do not know which is the frequency. Like, okay, let's check. Okay, there is, I will check now. I go to this website of the radio station. There is one local. I'm in Kurzem, and here we have one not in Riga. The transmitter is in somewhere like Tukums or somewhere more closer to here, but
So you are in Latvia, you are using different frequency for different cities for the radio communication.
yes, that's very strange because I don't know. I know that some stations use same frequency, but this is quite difficult because for the receiver it's difficult because if you receive several ones, they get this different delay into the receiver because the distance between the top to one tower is different than to another, and then it looks like a big echo coming inside of the receiver. And if the stations are powerful, the single frequency broadcasting is quite difficult to implement. But I don't know, maybe in Latvia, here we have also this Tukums 92.4.
Oh, but
Okay.
in my state in India, we are using a single frequency for much more distance. I mean,
Maybe they are not,
91.9 for
maybe you are not able to receive two stations simultaneously, and then it's not a problem.
yeah, but we are receiving more than 4 stations, I think.
Oh, then it looks like a big echo, like one big and 4 smaller.
Yeah, I don't know exactly what's happening there.
Yes, yes. I think the spectrum also sees the speed. This is very different. Oh,
Visiem namām vairs istabā,
and here,
kam var ticēt un kam atplest rokas, uzliek tēju un sapurināt. Nu ar kad var klusēt un kad laist uz āru,
you see, it
celtu
works.
izrakt un neapkārties.
So this is a main idea around here. So we build transmitters and receivers using blocks. But in some cases, like digital communications, we have a lot of blocks, like insane number of blocks to get it working. And this is, of course, this F-band, some blocks are already implemented in MATLAB. This F-band baseband demodulator, this is quite a complex one because it supports stereo and this also RDS and all this stuff going over the radio. And if I put here much simpler one, I believe the quality of sound would be much better because it will not try to handle on the stereo transmission and everything else. But okay, this is not the topic of today because we will do this laboratory work and then we will experiment. And also we will have a separate lecture for the FM transmission, and there we will build it from the scratch using very simple components as well. This FM demodulator could be built using 2 simple blocks. And of course it will not be stereo and so on, but anyway it will be working and you will be able to hear the sound. Okay, now we have like 20 minutes left. Let's go with the lecture and all this stuff. Okay, let's switch the share, go with this lecture slides. MATLAB preview here. Okay, This is not interesting. This is what I already said. Okay, we will need to, this book. This book can be downloaded from the internet. You can find those slides in the Ortus, and also there is, I think, a link to this book. If you go to the website, if you go to the website, like, can you share? Desktop SDR. .com or org, I do not remember. Oh, this is org. No. I know. There was a bug. It doesn't support. You should type www. Without www, it doesn't work. They have no forwarding to this shorter domain to the main domain. Okay, you go to this website, and this is some kind of advertisement. But here you have download, and here you can book. You can download the book, and this book has also 1.5 gigabytes of various models. All those models require this RTL-SDR, the small one, which I have now used. But they could be easily modified to the Pluto, and we will use a lot of materials from this book. And I can, of course, share this archive directly, but you can go and download, not a big deal, and you will get also the book. And this is the most important thing here. Yes, this Stewart, Kenneth Barley, RTL-SDR, software defined using MATLAB. This is very good book, really good. And there is also other books which are using. And there's last ones are just, in general, very good books about the communication. Okay, later, now we will go to to some difficult part of all this stuff. In general, we have to understand a little bit about, because mostly this is about the modeling and the programming. And generally speaking, you do not have to be very big specialist in the hardware and all this constructions of the SDR inside. But we have some time also dedicated to build to internals to this SDRs, because when you, for example, working for someone or purchasing SDR, you have to understand the capabilities and what it can do and what it can do, because usually they write the type of the receiver which is inside. And that's why I little bit give some words about this. So in general, you see the receiver could be built very easily, like this. Yes, I have built such receivers in the childhood. This is kind of very long wire here. It is like bent around some ferrite stick. Then you have some capacitors with a change. You can change capacity like plates moving against each other. You can see this in the corridor in the faculty. Then you need any diode. And theoretically, you can connect headphones already here. But then you need very strong middle or long wave radio station. It will not work with FM. And nowadays, we do not have such radio stations in Latvia. So nowadays, kids are out of luck to use such receivers. And FM will be more complex. And here, we have one transistor amplifier as well. And then you will have excellent, strong signal in case of the short of medium and long waves. And this also could be implemented in very simple software-defined radio. Yes, like you just put here analog to digital converter, and here instead of the capacitor, you put digitally tunable element to adjust the frequency. And but this will be direct conversion receiver, so-called, and it will be relatively poor because this filter, it's very difficult to build this filter here to very broad range of frequencies. You know, for example, this Pluto works from like 50 megahertz until 6 gigahertz. Such filter in such broad range, it's unreal to build. Yes, that's why there is different strategies. And maybe I will skip this and we will go to the receivers. So what is ideal software-defined radio? Ideal software-defined radio would be such that you connect analog to digital converter directly after the antenna. Yes, so that you do not have any pre-processing here, just some small filter, and then you just digitize everything. Why it is good? Because you can simultaneously receive many frequencies. For example, if we would use such software-defined radio in our mobile phone, we do not need separate chip for the Bluetooth, separate chip for the Wi-Fi, separate chip for the 4G, separate chip for the 3G. Nowadays, we have a lot of different circuits for different standards because it is cheaper than this approach. Because because you need the analog to digital converter for twice of the maximum frequency. For example, nowadays, I think some phones have 5 gigahertz Wi-Fi. That means that you need 10 gigahertz or more, like 12 gigahertz analog to digital converter and very powerful signal processor. And this is already used in some military radios because it's possible to build, but such receiver will cost $1 million and nobody will buy such a mobile phone. And moreover, it will be huge in size because such ADC will require cooling, very exact power supply and everything. That's why it is used, but in special applications like military, space, everywhere when you need the flexibility and where you do not count money. Yes, you just build it. And also some very advanced SDRs nowadays are also in the mobile base stations. Yes, they also all totally programmable. Nobody is building 5G or 4G base stations. The base station is universal and you have software-defined radio and you can reprogram it to new standard or implement new, let's say, new functionalities, or for example, operator have bought new licenses for new frequency bands. It just reprograms software-defined radio on the base station, and then it can do the job without very hard reinstallation of the hardware. Moreover, usually part of the processing is done on the data center. So the software-defined radio is not connected to the computer or something like this. It gets connected via optical cable to the very powerful data center, and this data center is doing this hard job, what our computers are done with the MATLAB, and it could process it. And this data center usually serves maybe tens or hundreds of the base stations simultaneously. Yes, and how it works, and you can easily shut down or run some additional virtual machines if you have some additional base stations or something like this. So theoretically, we also could run MATLAB on virtual machine, yes, and then we can run several software-defined radios on the one computer. But then we will need quite powerful computer to do this job, yes, and also, by the way, you can run several SDRs in one MATLAB model. One Simlink model can support several, but then this input-output will be quite overloaded in the computer. I don't know it will. I will try it with 2. Okay, it works, but if you need 100, it will not work. So the most software-defined radios which we are using are designed in this manner, which is shown here. Then this is so-called baseband software-defined radio, where you run analog tuner here in the front of the receiver. Okay, it's analog, but of course it has digitally controlled tuning. Yes, it has. For example, this green box has this Raphael. It has inside some small chip for this tuner. Yes, and it works very well. This is a small one. Yes, but this in nature it's analog. There is no sampling. Yes, everything is done in analog. Only these generators and maybe filters are controlled by some digital switches, but nature is analog. And then this analog comes to the amplifier, and then it gets amplified, and then it gets one more down conversion from the intermediate frequency. Again, it's analog, using quadrature down conversion. I will not spend a lot of time on this. This is a method how to separate in-phase and quadrature components. You can multiply by sinus and cosinus, and then how you get it. This is a topic of the next lecture. And after mixing, you have, because if you multiply 2 sinusoids, you will get sum and difference between frequencies always. That's why we need filter to remove this sum component and leave only this low frequency component around 0 frequency. And here they get, for example, if you now for the FM stations, this maximum frequency here is like 200 kilohertz only. So analog to digital converter could be working at 1 megahertz or something like this. And this is not 10 gigahertz. Yes, it's super cheap analog to digital converter. Actually, in this one, we have 28 megahertz analog to digital converter. But this is not a big deal. Now it's very cheap. You can buy such ADCs, I think, now are already in the microcontrollers for cents. Yes, and this is not a big deal. And then this gets sent to some pre-processing. Here it's digital one, but it's very primitive. It doesn't do any big job, just remove some redundant samples, and then it sends to the computer. No further processing happening. So actually it's like a sound card, yes, but only for the radio waves. It receives radio waves, converts them, and sends to the computer. And the computer does the rest of the job. You can use any software which is capable to do the job. You can write special program, you can use MATLAB, you can use some GNU radio, for example, and there is a lot of specific like GQRX and also some special software for the monitoring, for the interception of the data, and lot nowadays. This direction is developing very fastly, and there is a lot of spying software for the software-defined radios. You connect the software and you can spy on police, spy on the airport data, and so on and so on. Now that's why this encryption and everything becomes very important, because this stuff becomes really available and all this software could be downloaded from the internet. And some words about the history. We have 5 minutes left. So this direction start to develop like in 80s when the computers start to develop, and this is some kind of US military first used, and like 2 very popular projects for the 90s. And nowadays, as already said, okay, there is no any picture. Maybe I can share it, like. You need replug. Yes, because I have used this SDR, I have unplugged. Document. This is CRAN. Yes, what is a CRAN? CRAN is cloud radio access network. So what does it mean? So I already said how nowadays the mobile network works. We have a tower. On the tower we have antenna. Then this cable goes down. Okay, no, even like this. Here we have so-called radio head. This is in fact software-defined radio unit. Which does conversion of the samples into the electric signal sent to the antenna. Here we have optical cable going down. Or it could be also some kind of microwave. Maybe you see on the mobile towers those microwave antennas. It's like, looks like a cylinder, like a dish. Yes, and this is more frequently. Instead of optical cable, we have like this antenna here. And it sends to another antenna. to another tower. Then it has another antenna. And finally, it gets to the data center. And it does all this signal processing for those radio heads. And then it also sends to another data center, which is maybe it's running on the same data center, all this telephony stuff, because there is also from this signal processing part, you have those samples, which I have sent now to the speaker of the computer, but it goes to all this telephony, like connecting different subscribers, signaling, SMS, and all this stuff going over the radio. This telephony, it could be also internet, and so on and so on, and how it works nowadays. And this is the software-defined radio. In this radio head, it's plays very important role, because nowadays, of course, only few base stations are built like this. Usually we have now still big box here, and it does a lot of things, gets a power for this, and so on and so on. And you do not have radio head, but instead we have some waveguide going down from the antenna to this, and here we do this SDR or what else, and then it goes back to this antenna. But theoretically, you can build this radio head so small that it installed on the tower. You do not need this very big house at the bottom of the tower, and a lot of power as well you do not need. It even could work, for example, from some, I don't know, wind energy or solar or something like this. Okay, this is about the Cloud Run. And also there is direction of the cognitive radio. This is a smart radio, which is still in the development progress. That there is idea that you can build such transmitters and receivers that you will not specify frequencies, standard modulations, anything. The radio is so intelligent that it can find the frequency, the modulation, and everything automatically, so that radios speak with each other at any frequencies which are available now. So, for example, you can, instead of using Wi-Fi for 2.4 gigahertz, you just buy Wi-Fi, which is working in all frequencies, and it automatically finds the frequency for the connection with another device. But this is still in very early stage, because it is now all the frequencies are quite statically allocated for the different uses, and nobody still wishes to go with this cognitive radio, and although it would allow to use frequencies much more efficiently. And of course, now with the ultra wideband, when the bandwidth of the signal is like gigahertz and something like this, it could be not, these cognitive ideas not that be very applicable. Yes, and maybe, but this intelligence, this is a great book. Yes, you can read this if you have a time or look. It is written in the 90s about the language. This Josep Mitola developed special language, programming language, how the radios could talk with each other. And now with the machine learning and artificial intelligence, maybe some of these cognitive radio ideas could come alive. Okay, and there is few words about hardware. Yes, it's like RTL SDR, which I have talked about. This is very popular USRP. We have a lot of USRPs also university. And Adal Pluto, of course, Hack SDRF, iSpy, lot. This is quite old list because now other are popular. Software side is GNU Radio. Very popular software. It looks like Simlink, but it is free of charge. Yes, sorry, Zem, I'm looking in different direction because your pictures are in different screen. Then MATLAB, which we are using because it's most simple to use. And there is a GQRX, SDR Sharp, Cubic SDR, and this is like a tool. For example, you can download it for Windows and you can just, it is not like a flowchart or Simulink. You just connect, you can just, you run this and like, it is like, it looks like a receiver, yes, just on the screen receiver. You can select the frequency, tune on this frequency and then listen. Then you can switch to the modulation format. You can select some filters. It's like it looks, those GQRX and SDR Sharp look like very advanced receivers, but they receivers are like not hardware receivers, but software, like you just run very nice Windows program. And that's this SDR Sharp especially, it's very nice and a lot of capabilities, and it is super popular. Maybe I can show you the picture. Share. And this just looks like this, you see. See it how it looks. Yes, this is not like Simulink. You just can tune and look to the spectrogram, look to the spectrum. So it's quite powerful tool to, for example, if you are searching for something, yes, in the spectrum. Okay, this is about the softwares. And some people that this is a software-defined radio, but this is just some small program for this. The software-defined radio is much more wider term. New share. Okay, go back to my presentation. What else I could say? This is not important. Okay, this is some websites. Yes, this is website devoted to RTL SDR, and this is to desktop SDR. So this is actually introduction about the SDR. Not very practical, but we try to run receiver. On the next week, on the first lecture, we will go with this complex baseband. And in the second lecture,